All right, these are the notes for Chapter 2, Section 1. We are now doing transformations of quadratic functions. So we've done linear and we've done absolute value. The method is the same as it was with absolute value. It's just now our graph doesn't look like a V, they look like U's. That is the graph of a quadratic. And a quadratic just means x squared is the parent function. Okay, so we had vertical translations before, and this was just moving up or down. And that's that number tacked on to the end. That's what moves it up or down, just like it did with the absolute value functions. We have horizontal translations. That's a number grouped with x. We just do the opposite of it, and that's what moves us left or right, just like it did before. And we have reflections over the x-axis. If in front of x squared it is negative, it reflects it down. Okay. There's also reflections in the y-axis. It's when grouped with x, like inside with x, it's negative in front. That does exist, but that is not part of Algebra 2 curriculum, so we are actually not covering that this year. I just want to make you aware that it is possibility in case in the future in another class you see that and say, oh, that doesn't work. Well, it does. It's just we're not learning it this year. It is future math for you. And then we've done vertical stretches and shrinks. That's that number in front of the x, or in this case x squared, and that does stretch if a is greater than 1, and it does a shrink if a is between 0 and 1. Okay, so that's when it stays, starting point stay the same. If it stretches, it gets up tall, and if it shrinks, it gets wider and flatter. Okay, again, there's horizontal stretches and shrinks if inside parentheses that a is in there with the x squared, but we also don't cover these in Algebra 2. So everything that we've done so far, the vertical translation, the horizontal translation, so moving up and down or left or right, we've done that, as well as reflecting it and stretching or shrinking it. Okay, it's all the same, we just have a different shape of our graph. So somewhere on this front page, I want you to put, save a little room, but I want us to draw the parent function of f of x equals x squared. Okay, this is what just the parent function looks like. So if I draw a graph, I know I could keep going with my tick marks, but that's going to be good enough. Every time you're graphing a quadratic, you need to memorize the points that we're going to provide here, okay? All parent functions start at 0, 0. Now, if I plug 0 in for x, 0 squared is 0, so that's where that comes from. Now, if I plug 1 in for x, 1 squared is 1. If I plug 2 in, 2 squared is 4. If I plug 3 in, 3 squared is 9. Okay? So these are the points to memorize. 1, 1, 2, 4, 3, 9. So once you start, so in this way, in the parent function, there's no shifting left or right or up or down, so we're starting at that 0, 0, and we put a point. From that point, that's our vertex. From that point, I'm going to graph these. I'm going to go right 0, well, that's 0, 0, sorry, right 1, up 1, and I put a point. Now, this graph is a U. It is mirrored at that vertex, okay? At a vertical line at that vertex. So I'm going to go right 1 and up. I'm also going to go left 1 and up. I just go this way and put another point. And then I start again at that vertex, that starting point, and now I'm going to go right 2, up 4. Right 2, up 4. And I mirror it. So I also go left 2, up 4. And then if I would have given myself more space, I would have gone right 3, up 9, and left 3, up 9. But I didn't really give myself that space here, but there is what the parent function should look like. Those are the points of the parent function. No shifts and no stretches or shrinks.